It's in a wrapper. What's wrong with it? It's in a wrapper. Oh, it wasn't. Oh, I thought it was still in the wrapper. Oh, yeah, then no. Yeah, then no. Then 100% no.
That one's in a wrapper.
That one's in a wrapper. All right, factor. Factor complete, please. So we look at the first half, and I GCF that. What can I yank out of there? Let's see. 2 for the number, and x squared for the variable. 2x squared. And that leaves me with 7x plus 4. Yep. Out of the second half here, -1. And that's going to leave me with 7x plus 4. Okay. Out of both, I can pull out a 7x plus 4. And that's going to leave me with 2x squared minus 1. Can I factor 2x squared minus 1? Yes? What? Are they though? The 2 is not a perfect square, so that means that 2x squared is, x squared is, but the 2 isn't. So that means it's not. Right? Like yesterday we had 4x squared. 4 wasn't perfect square. X squared was perfect square. So that one is. Okay? With me? Okay? Right? So that can't be factored anymore. So then that's just our answer. Where did it come from, or where did it go?
I see where it came from.
Okay.
Go down.
Right here. And then right here. Yeah. So basically what we did is, we GCF'd in green, we GCF'd in blue, and then from here, they both had a 7x plus 4. So we GCF'd that, pulled out that 7x plus 4 as a unit, and we're left with 2x squared minus 1. And then what we were talking about up here was this 2x squared minus 1 factor. And if this 2 would have been a perfect square, then it would have been a perfect square minus a perfect square. All right. So yesterday, after we got done factoring, then we talked about the fundamental theorem of algebra. That told us that the degree, what's the degree again?
The greatest
biggest exponent. Yep. Biggest exponent tells us how many answers we need to get in the end. Okay? So that's the fundamental theorem. Right now, we're only going to find real solutions in a week and a half. Week and a half, then we'll get into complex numbers and we'll get into that. Okay? And so we've got 5 different ways to factor right now. We should always GCF first. Then we look for difference of perfect squares. Then we look if it's a trinomial, we do the 2 parentheses. I call it the butt cheek method. Then we've got our cubic formulas. You will not get your cubic formulas tomorrow on the quiz, I don't think. I gotta look and see. I'll get it. I will get you a confirmation of that. Yes, today. And then we've got the formative tomorrow. Yes. Formative tomorrow, summative the next 2 times. I won't say the next 2 weeks, because next week that will be happening. Nothing next week. Refresh my memory. Before we even start factoring to solve, what do we have to get our equation
to equal 0?
Equal 0. We've got to have it equal to 0 first. So right off the start, we've got to subtract. That gives me then 98x squared minus 42x plus 4 equals 0. Is there a common factor?
2.
2? 2, yes, because they're all even for sure. Is 4 1? That's a great question. Because
No,
4 would be
because of-
bigger.
Because of negative 42x.
Yep. And 4 doesn't go into 42?
Yeah.
Yep. 4 doesn't go into 42. 4 doesn't go into 98 either. So not 4, but 2. Okay? All right? Any x's that we can pull out too? Nope. Okay. So we just have 2. What's going to be left over then? 98 divided by 2. 49. 42 divided by 2.
21.
4 divided by 2.
1.
Nope. 2. Now we got to look at that trinomial and see if that's factorable. If it is, right? If it's not, then we got to use the quadratic formula. Okay? So if it is, yes, good for us. If it's not, ruh-roh, we got stuff to do there.
Okay.
Think so? I'm going to try 7x and 7x just because they're right in the middle, not very extreme. Okay? Then if I went 2, I only got, my choices are 2 and 1, right? Both positive, both negative, or one of each. What does this sign right here, that sign right there, what does that tell me? That those two signs are the same, okay? What does this sign then also tell me? It's got to be negative, all right? So let's try negative and negative. Then if I try that, I get negative 14x, and I get negative 7x there. Combined, they give me negative 21. Factorable. I didn't want to have to multiply by 49. Okay, so we're good there. Okay. So then this would factor to be 2 times the quantity 7x minus 2 times the quantity 7x minus 1. And that is still equal to 0. Okay. Can we do any more factoring? No. So we have factored as far as we can. So now what do we do? How?
By having all the x's equal.
Set all of my factors equal to 0, right? Okay. So I'm going to set all of my factors equal to 0. Can 2 ever be 0? Nope. Yeah. Here on this one then, we could add 2. Then we could divide by 7. And I get 2/7. Over here we can add 1. Then we can divide by 7. Right? So we get 2/7 and 1/7 for our answer. Now, I will tell you, don't put, if you write it like this, okay, so you could give me this as your answer. You could literally just circle that as your answer. I'd be fine with that. Okay? you could write it like this. Okay? But if you do write it like that, you gotta resist the urge to put parentheses around it. Because if you put parentheses around it, then it becomes a point. And that's different than these two x values. Then you got an x and a y value. Okay? Or if you wrote it so you can give your answer in any of those three. Okay. Questions, comments, concerns, clarifications? Love it. You do it. Find me all the real solutions. Try this one. First thing I gotta do, set it equal to 0. So which way should we go? Should we bring everything left or should we take everything to the right?
Take everything to the left.
Left, yep. Okay, so I'm gonna add 45 t squared. I don't know why that changed there. That's kind of creepy. Probably it's recognizing the. And I'm gonna subtract 3t. So I'm gonna add 45t squared. I'm gonna subtract 3t. That's going to then give me 27t cubed plus 45t squared minus 3t minus 5 equaling 0. Grouping, right? 9t squared leaves me with 3t plus 5. Why is this one isn't correct? It must be on a certain angle for that. And then on this one, it's going to be a minus 1. And that's going to be a 3t plus 5. Then it's going to be, oops, see, there it was. It's recognizing the different sizes. 3t plus 5 and 9t squared minus 1. 9t squared minus 1, can it be factored?
Yes, because it is perfect square.
Minus perfect square, right? Yep. Perfect square minus perfect square. Kicker is actually the minus part. So then this becomes 3t plus 5, 3t minus 1, and 3t plus 1. Now we can set those. So I get t is negative 5/3, t is 1/3, t is negative 1/3. Yes? If you wanted to go plus or minus 1/3 there, you're giving your answer. Questions, comments, concerns, clarifications? One more. Go for it. No, not all you get is x minus 3. Okay,
You
is
get
it?
it.
Is,
Three as
no,
well.
is it factorable?
Yes,
Yes, what kind of factoring is it?
cubic.
It's a cubic minus a cubic, right? Okay, so this is gonna factor to be, so this is like x cubed minus 3 cubed, right? Okay, so this factors to be x minus 3 times, I gotta square this one, I gotta square that one, and then I gotta multiply those two together and change the sign. Our cubic formulas from Monday. When I dropped the big hint before that said you might want to look back in your notes from Monday, that's what you should have gotten. Okay? And then what did I say on Monday about this trinomial? What did I say about the trinomial on Monday? What did I say about it? The thing that makes it easier, especially when we're solving with it. Is it factorable? No, it is not factorable. So you can't go any further than this. Okay? So now we set our factors equal to 0. Okay? Now we can apply our quadratic formula. X is equal to opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Three squared is 9. 4 times 1 times 9. Four times 1 times 9. 36. 9 minus 36. Negative 27. Do I need to go any further? Why not? Yes, right? Because why? Why can't we go, or why don't we need to go any further today? Because it's going to be an imaginary solution and we just asked for the real ones. Okay? Right? So 3 is our only answer, but there are 2 other imaginary solutions. Yes, Dan? That would work for today, but it wouldn't work for next week. So let's not. Let's get rid of those bad habits right away. Because next week, we're going to find all 3. Well, I think next week we just talk about the complex numbers and then the following week actually get to solve it with complexes. Okay? Alright? So I'm giving you a mod to work on homework for this week. It's gold this week. Okay? So you got homework, a gold homework this week. If you have any old homework that are not at 100%, fix them. Get them to be 100%. Okay? Same with old formatives too. And then tomorrow, gold is due, and you have formative tomorrow too.